Hello everyone, good evening. So here we shall solve some more KCET previous year questions on the chapter Haloalkanes and Haloarenes. So any doubts if you have in any steps of the solutions, then please write that in the comments section. We shall obviously clarify them either in the comments reply or in the subsequent videos. Also in any other chapter of chemistry, if you have more difficulty, then please mention the name of that chapter also in the comments section, um, so that we can give more priority on it and solve more and more questions on that chapter. Also, some important homework questions on every chapter of chemistry will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here it is told that how many optically active stereomers are possible for butane 2,3 diol. So we have butane, so 2,3 diol. So it is like this. So it is, so its name is butane 2,3 2,3 diol. So here so if we draw its structure, then we see that here we have two chiral carbons. One is this and one is this. So chiral carbon, or it is called the asymmetric carbon. It means that asymmetric carbon, which means that all the four groups which are attached to that carbon are different. So if the four groups which are attached which are attached to the carbon are not same or are different, then that carbon is called as the chiral carbon or asymmetric carbon. Then it is called the chiral carbon. So now here we have two chiral carbons. So now therefore the rule is that the number of optically active isomers, the the number of optically active stereo um, the number of optically active isomers, that will be equal to 2 power n. 2 power n, where n is the number of chiral carbons. So here n equals to 2, since we have two chiral carbons here. So it will be 2 power 2, that is 4. So now, the, and out of these optically active isomers, one of them is the meso compound. Now the meso compound is optically inactive. The meso compound is optically inactive. So if we exclude that meso compound, so then the number of optically active stereoisomers, the number of optically active stereoisomers, that will be equal to 4 minus 1, that is equal to 3. So it means that option A is the correct answer. Now here it is told that N-propyl bromide on heating with alcoholic KOH produces. Now N-propyl bromide. N-propyl bromide, that is so N-propyl, that is CH3, CH2, CH2, Br. So now if it is treated with alcoholic KOH, now KOH will give OH minus ion, which is a nucleophile. So there will be a nucleophilic substitution reaction. So OH minus ion will attack here and this Br minus ion will be removed. So then it will form CH3, CH2, CH2, OH. So it will be uh, propanol. So now here alcoholic KOH is used. Alcoholic KOH. So when this propanol is formed, then one H2O molecule will be removed. Then it will form CH3 CH CH2 plus H2O. And this Br minus ion will link with the K plus ion, then and KBr will be formed. So it means that here we will have dehydrohalogenation. It means that one HBr will be removed. So propene will be formed. So option D is the correct answer. Then here it is told that an organic compound on heating with cupric oxide, the organic compound on heating with cupric oxide produces CO2 but no water, but no water. The organic compound may be. The organic compound may be. Since the compound on heating produces CO2 and no water, hence it means the compound has no hydrogen. So it means the organic compound should have it should contain no hydrogen atoms. So now in case of chloroform, which is CHCl3, we have hydrogen. So it means that so it should not be chloroform. Then in methane is CH4, so it has got hydrogen, so it should not be the compound. And ethyl iodide, which is C2H5I, it should not be also the compound, since why it contains hydrogen. And in option D, it is carbon tetrachloride, which is CCl4. So here it has no hydrogen, so it is the required compound. So option D is the correct answer. So carbon tetrachloride only, when on heating with cupric oxide, will produce CO2 and no water will be formed. Then dibromo derivative of an alkane. A dibromo derivative of an alkane reacts with sodium metal to form an alicyclic hydrocarbon. The derivative is, so first one is 1,1 dibromopropane, 1,1 dibromopropane, which can't be, and 2,2 dibromobutane, 2,2 dibromobutane, which also can't be the compound, and 1,2 dibromoethane, 1,2 dibromoethane, which also can't give a alicyclic hydrocarbon. Only if we use 1,4-dibromobutane, so it is 1,4-dibromobutane, when this will react with sodium, then it will produce an alicyclic hydrocarbon, which is the cyclobutane will be formed. Since why it will remove this, these two bromine atoms will be removed in the form of Br, Br2, and and one cyclic ring will be formed. So it means option D is the correct answer. Then reaction of methyl bromide with aqueous sodium hydroxide. Reaction of methyl bromide with aqueous sodium hydroxide involves. And so here OH, from NaOH we will obtain OH minus ion, which will uh, so here so when aqueous sodium hydroxide solution is used, then it will follow SN2 mechanism. SN2 mechanism will be followed, which is bi molecular nucleophilic substitution reaction. Full form of SN2 is bimolecular nucleophilic substitution reaction. So when it will follow the SN2 mechanism, so there will be obviously the inversion of configuration. It means the inversion product will be formed. So it means that option C and D both are correct options. Then it is told the maximum number of possible optical isomers in 1-bromo-2 methyl cyclobutane is 1-bromo-2 methyl cyclobutane we have, and the maximum number of possible optical isomers in 1-bromo-2 methyl cyclobutane. So the structure is somewhat like this. So here the molecule has no symmetry. So here as we see that the molecule has no symmetry, no line of symmetry also, and no plane of symmetry also. It means it can't be divided into two equal halves. And so now here, therefore here we have one hydrogen and one hydrogen here. So here we have, here also we have, here also we have two hydrogens. Here we have two hydrogens. So we have two chiral carbons here, or two asymmetric carbons. Therefore, the number of optical isomers, that will be 2 power n, where n is the number of chiral carbons. So here n equals to 2. So here 2 power n, here 2 power n, that will be equal to 2 power 2, that is equal to 4. Then so now therefore the number of meso compounds here, the number of meso compounds, that will be 0 only, since why here we have no line of symmetry. In the first question here we had um, in the first question here we had one line of symmetry. It means, so it means that here we will have one meso compound, but here there is no line of symmetry, so here there will be no meso compounds. So now therefore the total number of optically active isomers, that will be 4 plus 0, that will be equal to 4 plus 0, that is 4. So option A is the correct answer. Then it is told which one of the following is not true for the hydrolysis of T of tertiary butyl bromide with aqueous NaOH. Which one is not? So now tertiary butyl bromide. Tertiary butyl bromide, its structure is like this. Tertiary butyl bromide. Now when it will react with aqueous solution of NaOH, then here the OH minus is the nucleophile which will attack here. So now so here it will follow the SN1 mechanism. SN1 mechanism will be followed, since why here aqueous solution of NaOH has been used, which is a polar protic solvent has been used. So when polar protic solvents like H2O or NaOH has been are used, then the reaction will follow SN1 me mechanism. The full form of SN1 is unimolecular nucleophilic substitution re reaction. Unimolecular nucleophilic substitution reaction. So here OH minus will attack here. Then therefore the reaction will follow SN1 mechanism, and here so obviously the carbocation will be formed, and since why here tertiary butyl carbocation will be formed here, and the rate of the reaction doubles when the concentration of alkali is doubled, which is wrong, since why here the first step, so here the rate of the reaction will depend only on the concentration of the haloalkane, on the concentration of the alkyl halide. Since why here the SN1 reaction, it involves the first step. Step 1 is the slower step, slow and reversible step, where from Rx we obtain R plus, which is the carbocation, and X minus. So it is a reversible step and it is a slow step. And as we know that the rate of reaction will depend only on the slow step. And the step 2 is a faster step, where the OH minus will attack the R plus, and then it will form ROH. So it is a fast step, so on it the rate will not depend. So it means the rate of the reaction is independent. The rate of the reaction is independent of the concentration of the NaOH, and it will depend only on the concentration of the alkyl halide. So hence C is the wrong statement, and so C is the correct answer. And in option D, it is told that the rate of the reaction doubles when the concentration of tertiary butyl bromide is doubled. So which will be true. Then it is told following is the substitution reaction in which cyanide replaces chloride. So now to obtain propane nitrile, RCl should be. So if we want to obtain propane nitrile means CH3 CH2 CN, CH3 CH2 CN, which is called propanonitrile. So then the alkyl group should be, the R group should be the ethyl group. So it should be ethyl chloride, or I can say it is chloroethane. It should be chloroethane. So option A is the correct answer. So if chloroethane will react with with alcoholic KCN, then only we will obtain this propanonitrile and KCl. Then here it is told that which of the following is not true for SN1 reaction. So now SN1 reaction is obviously it is favored by polar protic solvents. So whenever there is a polar protic solvent like H2O or alcohols or NaOH, KOH, etc., then only SN1 reaction will be favored. Then in option B it is told 3-degree alkyl halides generally react through SN1 reaction, which is true. Then the rate of the reaction does not depend upon the molar concentration of the nucleophile, which is also true. Since why the nucleophile will attack the alkyl carbocation in the second step, which is a faster step, which is a fast step. So on this step, the rate of the reaction will not depend. The rate of the reaction will depend only on the slower step, which is the step 1, where the carbocation will be formed, where the carbocation is formed from Rx, it will form R plus and X minus. So it is a slow step and it is a reversible step. So on it, so it means that the rate of the reaction will depend only on the molar concentration of the alkyl halide and not on the concentration of the nucleophile. And then 1 degree alkyl halides generally react through SN1 reaction, which is false. So the order of the reaction for SN1 re reaction, the reactivity order is that for 3-degree carbon more than 2-degree carbon, more than 1-degree carbon, and more than, which is more than uh, the methyl group. So it means that if more, so it means that more substituted carbon if I have, it will follow SN1 reaction, and if we have less substituted carbon, then it will not follow the SN1 reaction, it will follow SN2 reaction. So option D is the wrong statement. So option D is the correct answer. Then here it is told the number of optical isomers of the compound CH3, CH, Br, CH, Br, COOH. So here we also have two chiral carbons or two chiral centers, and here there is no line of symmetry also, there is no line of symmetry. So, or I can say no axis of symmetry. So therefore no meso compounds will be formed here. There is no meso compound, and so therefore the number of optically active isomers here, that will be equal to 2 power n, where n is the number of chiral carbons, which is 2 here. So that will be 2 power 2, that is equal to 4. So 4 optically active isomers. So option D is the correct answer. Then it is told that meso compounds do not show optical activity because they do not contain chiral carbon atoms, which is false. They have non-superimposable mirror images, which is false. They contain plane of symmetry, which is true. Since why? They contain one plane of symmetry. So option C is the correct answer. Then it is told that bromide, an alkyl bromide, which is in the form of RBr, which is the AX, it reacts with sodium in ether. It reacts with sodium in the presence of ether, I can say Et2O, to form 4,5 diethyl octane. So it forms 2,5 diethyl octane, means there are 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8, and so 4,5 diethyl. So we have 4,5 diethyl octane. We have one hydrogen here. So here also we have two chiral centers. Okay. Then here the compound X is, now when alkyl bromide will react with the rule is that if RBr reacts in the presence of sodium in ether, then it will form RR and Br2. It means from the two alkyl groups, or from the two alkyl bromides, the bromine will be removed in the form of Br2, and this alkyl group will link with the same alkyl group to form a new alkane. So here it means we can take this part as the alkyl group. So therefore here the alkyl group should be CCC and CC, and here it should be Br. So it means that it has to be 1, 2, 3, 4, 5. So it is 3 bromo. It should be 3 bromo pentane. So in the option D, here we have 3 carbons, and here no, here we have 6 carbons. No, sorry, here 1, 2, 3, 4, 5, 6. It should be 6 actually. The third carbon, 3 bromo, it should be hexane. 3 bromo hexane. Okay. Yeah, so option D is the correct answer. Since here we have the bromine substituent which is attached with the third carbon. Option D is the correct answer. Then here it is told which of the following pairs are correctly matched. Which of the following pairs are correctly matched? So here alkyl halide that reacts with AgCN to, since why from AgCN we get isonitrile as the nucleophile, and then it will react with Rx to form RNC, which is alkane isonitrile, and AgX, silver halide. So it means that the second one is correctly matched. And in the first one, Rx reacts with AgOH. Here, actually, OH minus ion will attack Rx. So here ROH should be formed, but here RH has been told, which is not correct. So the first one is wrongly matched. And then the third one is Rx plus KCN. From KCN, as we know, cyanide ion will be used as the nucleophile, and that will form RCN plus KX. So third one is also wrongly matched. And in the fourth one, it is told Rx plus Na, that will obviously form RR plus 2 NaX. So fourth one is correctly matched. So 2 and 4 are correctly matched. So option D is the correct answer. Then here it is told cycloalkane formed when 1,4-dibromopentane is heated with sodium is. Cycloalkane formed when 1,4-dibromopentane 1,4-dibromopentane is heated with sodium, then one cycloalkane will be formed. So these two bromine atoms will come out in the form of Br2, and no, in the form of 2NaBr. Then it will form, so 4 carbon chain and 1 methyl group. So it will be methyl cyclobutane. Methyl cyclobutane will be formed. So option A is the correct answer. Then it is told an incorrect statement with respect to SN1 and SN2 mechanisms for alkyl halides. The incorrect statement with respect to SN1 and SN2 mechanisms for alkyl halides. So a strong nucleophile is in an aprotic solvent increases the rate or favors for SN2 reaction, which is true statement. Since why, as we know that SN1 reaction is favored in case of polar protic solvents. In polar protic solvents, and SN2 reaction is favored in aprotic solvents, aprotic and or non-polar solvents. So here when strong nucleophile is used, then also SN2 is more fa favored. And then it is told competing reaction for an SN2 reaction is a rearrangement, which is false, since why the competing reaction for an SN2 reaction is SN1 reaction. And option C is told that SN1 reactions can be catalyzed by some Lewis acids, which is true. Then a nucleophile, a weak nucleophile and a protic solvent increases the rate or favors SN1 reaction, which is true. So the competing reaction for an SN2 reaction is not rearrangement. So option B is the incorrect statement. So it is the correct answer. Then it is told the arrangement of the following compounds in the increasing order of their boiling point is. So we have to write the increasing order of their boiling point. So the first one is bromomethane, bromomethane. The second one is bromoform, which is CHBr3. Then we have chloromethane, and we have dibromomethane, CH2Br2. So now, as we know that when there are more heavier groups uh, uh, attached, if the molecular mass of the compound is higher, then the boiling point also will be higher. So now here it means that the so it is the 1, 2, 3, and 4. Okay. So now the least molecular mass is for chloromethane only. So it means that CH3Cl will have the least boiling point, and then we have CH3Br, and then we have CH2Br2, and then we have CHBr3. So it means that it should be 3 less than 1 less than 4 less than 2. So option C is the correct answer. Since why, the rule is that as the molecular mass of the compound increases, the intermolecular force also will increase. The intermolecular forces like the van der Waal forces will also increase, and which will increase the boiling point of that compound. So the intermolecular force also increases as the molecular mass of that compound increases. Then here it is told that the hydrolysis of optically active 2-bromobutane, the hydrolysis of optically active 2-bromobutane, which is like this 2-bromobutane, which is obviously optically active, since why here we have one chiral carbon here. So the hydrolysis of in the presence of aqueous NaOH results in the formation of. So here polar protic solvent is used. So it will follow SN1 me mechanism. So when SN1 mechanism is formed, is used, then a racemic mixture will be formed. Racemic mixture, it means an equal amounts of the D and the L forms, or I can say the plus and the minus forms will be formed. It means that it will form plus or minus butane to all. Butane to all. Since why here the OH minus ion, it can attack from one side or from the other side. So hence a racemic mixture of both the D and L forms will be formed, which will be this. This one is butane to all, but plus and minus both will be formed. So option B is the correct answer. And here it is told that mm, the uh, it is bromocyclohexane. So it is so when bromocyclohexane will react with Mg in the presence of dry ether, then it produces the compound A, and then when uh, when H2O in the presence of an acid is reacted with A, then it produces the compound B. So then the product B is. So when dry ether is used, then this here Mg will be linked with Br, so it will form MgBr here, which is the A. So it is of the form RMgX, which is also called the Grignard reagent. Grignard reagent, which is of the form RMgX, which is also called as an organometallic compound. It is an organometallic compound. So when it reacts with H2O in the presence of H plus, then H plus will attack here, and then this MgBr will be removed. And here MgOHBr, magnesium hydroxide bromide will be formed along with cyclohexane. Cyclohexane will be formed. So option D is the correct answer. Then it is told reactivity order of halides for dehydrohalogenation is. The reactivity order of halides for dehydrohalogenation is. So it is Ri more than Rbr, more than RCl, more than Rf. Since why? Here the carbon iodine covalent bond, it is having the least strength, and it is so it has the longest bond length. Here the it has the largest bond length since it has the least bond strength. So alkyl iodide is the most reactive. Alkyl iodide is most reactive in dehydrohalogenation to form an alkene. So option B is the correct answer. Then it is told which of the following statements is true in case of alkyl halides. So in case of alkyl halides, as we know that here the carbon halogen bond which is formed, it is a polar covalent bond. Polar covalent bond. Since why here, since the halogen is more electronegative than carbon, so on carbon a partial positive charge is formed, and on the halogen a partial negative charge will be formed. So they are polar in nature, and they can form hydrogen bonds, which is wrong. Since why hydrogen bond is formed when hydrogen is bonded with highly electronegative elements like fluorine, nitrogen, or oxygen, then only hydrogen bond will be formed. And they are highly soluble in water, which is false. And they undergo addition reactions, which is also false. So alkyl halides, it can undergo only nucleophilic substitution reactions. Only SN1 or SN2 reactions it can undergo. It can undergo only nucleophilic substitution. So it can't undergo addition reactions. So hence they are uh, polar in n- nature. So they are alkyl halides are polar compounds, obviously. So option A is the correct answer. Then it is told the tertiary alkyl halide is practically inert to substitution by SN2 mechanism because of tertiary alkyl halide. It means that it is here carbon is linked with three alkyl groups, then it is called a tertiary alkyl halide, and it is practically inert to substitution by SN2. Since why here when the nucleophile will attack, there will be a steric effect or the steric hindrance effect will be there due to the three alkyl groups which are attached to the carbon. So hence the SN2 reaction can't happen, or if it happens it will be a very slow SN2 reaction. So option D is the correct answer. Then it is told which of the following halides undergo hydrolysis with on warming with aqueous sodium hydroxide. So when we have aqueous sodium hydroxide with some alkyl halide, then the rule is that it will the alkyl halide will uh, undergo SN1 reaction. SN1 mechanism will happen here. Now, when there is SN1 reaction, then the alkyl carbocation will be formed. Now, as we know that the carbocation is more stabilized, the carbocation is more stabilized by electron donating groups. It is more stabilized by the plus I effect or the plus M effect or plus R effect, which is the resonance effect and the in inductive effects. So if some electron donating groups are there, then only it will be stabilized. So now in the first option, where when the phenyl carbocation is formed, it is not very stable. Since why it is not stabilized by plus I effect also or plus R effect also. In the case of option B, it is told that here here also phenyl carbocation, but here two NO2 groups are attached. So there will be plus M effect or plus R effect due to two NO2 groups. There will be plus R effect due to two NO2 groups. And in the case of option C, here we have one NO2 group which is attached in the para position. So the one NO2 group is attached in the para position with respect to Cl. So here when the carbocation is formed, then here we will have the plus R effect due to one NO2 group of one nitro group. And then in the option D, here we have the phenyl carbocation which is formed here. It will experience plus R effect due to three NO2 groups. So it will experience the plus R effect of three NO2 groups. NO2 groups. So here the carbocation is most stabilized. So hydrolysis, it means that Here OH minus it will attack here and it will form ROH. Alcohol will be formed. So here this carbocation is the most stable. This carbocation is most stable. So it will undergo hydrolysis on warming with aqueous NaOH. So option D is the correct answer. So the compound having l- longest CCl bond is carbon chlorine bond is. Now here in the first one, here the bond order is one only, and in the option B here, so here there is no plus R effect. There is no p- plus R effect, but here there can be plus R effect since on chlorine we have three lone pairs, so one lone pair can come here. So the here the bond order can slightly increase, so it is slightly more than one. Now here this pi electrons can't have the plus R effect with this chlorine lone pair. So here there can't be any resonance structure which can be formed here. So there is no plus R effect here. But in the case of the option C, here we can have the plus R effect. Now here NO2 has plus R effect and okay. And chlorine also has got plus R effect. In case of option D, here also here can be plus R effect due to the lone pair here. So here also the bond order can slightly increase more than one. So it means that when the bond order, as you know, when the so here also the bond order can increase. This lone pair can have plus R effect with this um, can have plus R effect on this benzene ring. Now, as we know that when the so here also the this carbon chlorine bond order that will be slightly more than one. And now as we know that when the bond order increases, the bond length also decreases. So so here the bond order in the case of option B, here the bond order is one only. Since here there is no resonance effect, there is no resonance happening here. So here the bond order is the least, so the bond length will be the highest here. So in option B, we will have the longest carbon chlorine bond length. So option B is the correct answer. Then here it is told which of the following halide shows highest reactivity towards SN1 reaction. So now as you know that the rate of the SN1 reaction is directly proportional to the stability of the carbocation which is formed. The stability of the carbocation which is formed. Now here in the case of option A, here 1 degree carbocation will be formed 1 degree carbocation. And in the case of option B, here we have CH3, CH2, CH2, CH2I, CH2 plus. So here also 1 degree carbocation will be formed. And in case of option C, here we will have phenyl carbocation. We will have phenyl carbocation, which is also a 2 degree carbocation. And in case of option D, here also we have C6H5CH2Cl. So here also we have 1 degree carbocation. So 2 degree carbocation will be most stable. So the rate of the SN1 reaction will be the highest in the case of option. Okay. Okay, so here 2 degree carbocation is formed, but here in the, as you know that benzylic carbocation will be most stable due to resonance. Since here we will have resonance effect. Here we will have resonance effect, means this one can come here, then this positive charge will come here. So it means that the benzylic carbocation is the most stable due to resonance. So here, even though it is a 1 degree carbocation, but due to the resonance effect, the carbocation will be more stabilized. So the benzylic carbocation is more stable due to the resonance effect. So hence option D is the correct answer. Since why here the rate, here since the carbocation is most stable, so here the rate of the SN1 reaction also will be the highest. Now here it is told that in the reaction MgBr plus CH3NH2 dry ether X gives X, the number of possible isomers for the organic compound X is. So here we have isopropyl. Okay. So here actually the the organic compound X which will be formed is this one only, which means it is CH3, CH3, CH3 and H. So it is this I can call it isobutane. Isobutane will be formed plus MgBr and no, it will be NHCH3. So it means that from CH3 NH2 one H plus will attack here, and then this CH3 NH minus ion that will form the, that will link with MgBr. So here we have to find the number of possible isomers of this X, which is isobutane. So number of isomers, so here we can form one N-butane can be formed, N-butane, or I can form isobutane. So here it means 2 isomers can be formed. So option C is the correct answer. Then here it is told that prolonged exposure of chloroform in humans may cause damage to liver. Prolonged exposure of chloroform is CHCl3 in humans may cause damage to liver. This is due to the formation of the following compound. Now, as we know that when chloroform is exposed to air and sunlight, so in the presence of oxygen, chloroform will re- react to produce carbonyl chloride, which is COCl2, which is also called as phosgene plus 2HCl. So now phosgene, which is carbonyl chloride, it is a poisonous gas, highly poisonous gas, which can mm, so which can cause cause damage to the liver. So option A is the correct answer. Then the correct IUPAC name of this compound is, now here we have the phenyl group, means the benzene ring, and then NO2 here and F fluorine here, and here one ethyl group. So here the only functional group is the nitro group. Nitro group is the functional group here. So here we shall start from the numbering from F. So it will be 1, 2, 3, 4, 5, 6. So the name will be 4 ethyl. Since while naming we should follow the alphabetical order. So 4 ethyl, then 1 fluoro, then 2 nitro benzene. Option A is the correct answer. Then here it is told that the compound A, which is the major product, is. Now the compound A, which is the major product, is. So here Br2 is reacting under ultraviolet light, then it produces A. So here it will be a free radical substitution re reaction. So here the, as you know that benzyl free radical is more stable. It means when the free radical is formed, this one will be more stable. Since why here we will have the plus M effect. Which is the benzyl free radical, that will be more stable. So then the bromine free radical will attack here, and then it will form this CHBr, CH3 and NO2. Okay. So it means that option B is the correct answer. So it is the major product which will be formed. Since here the stability order of alkyl free radical is that 3-degree alkyl free radical is more stable than 2-degree alkyl free radical, which is more stable than 1-degree alkyl free radical, which is more stable than methyl free radical. Then here it is told the order of reactivity of the compounds C6H5CH2Br, then these in SN2 reaction is. So the first one is the phenyl group is there and CH2Br, this is there. This is the first one. And the second one is the phenyl group is attached with CH, and here we have another phenyl group, and here we have Br. The third one is we have one phenyl group and we have CH, and here we have CH3, and here we have Br. And in fourth one we have two phenyl groups and one CH3 and one Br. So here in the case of SN2 reaction, we should use the concept of steric hindrance effect. Steric hindrance effect. So here, when more heavier groups are attached, then there is more steric hindrance. So if the steric hindrance effect is higher, then the rate of the SN2 reaction will be lesser. Then the rate of the SN2 reaction will decrease. So here the maximum number of heavier groups is attached in the fourth one. So the fourth one has got least, the fourth one is least reactive. Fourth one is least reactive. Okay. Then here again we have two phenyl groups. So second one is slightly more reactive than the fourth one, and the second one is again less reactive than the third one. And since here we have in the first one we have only one heavy group, which is the phenyl group, so it is the most reactive in case of SN2 reaction. So it is 4 less than 2 less than 3 less than 1. So 4 less than 2 less than 3 less than 1. So option A is the correct answer. Then it is told the major product. The major product of the following reaction is, now here HCH2 double bond CH2OH, and here HBr is used in excess. So here we will have hydrohalogenation. Hydrohalogenation will be there. So then we will form CH3CHBr. So here, so the carbocation will be formed here, and here negative charge will be formed. So H plus will attack here, and Br minus ion will attack here. Since why here 2-degree carbocation is more stable than 1-degree carbocation, so here only the plus charge will be formed through um, through hit through heterolytic cleavage. Here there will be a heterolytic cleavage, and the carbocation will be formed here, and the carbanion will be formed here. So here it will be CH3CH Br, then CH2OH. Then here again, when HBr will again react with this, then here Br minus will attack here, and then CH3CH Br, and here again CH2Br will be formed plus H2O will be formed. Okay. So here it means that option A is the correct answer, which is the major product that is formed. Then here it is told, in the following pairs of halogen compounds, which compound undergoes faster SN1 reaction? So in case of SN1 reaction, we should use the concept of stability of the carbocation. Stability of carbocation. So if the stability of carbocation is higher, then the rate of the SN1 reaction will be higher. So here it is told that mm, so so in the first one we have uh, here the carbocation will be a 3-degree carbocation, so it is more stable than 2-degree carbocation which will be formed here. So here 2-degree carbocation is formed, so 3-degree carbocation is more stable. So for the first one, the reaction rate, the SN1 reaction rate will be higher for the first one. And in the second case, it is told that here also uh, 2-degree carbocation will be formed for the first one, and for the second compound, a 1-degree carbocation will be formed. So it means that 2-degree carbocation is more stable than 1-degree carbocation. So this the first compound is more stable, will undergo SN1 reaction at a faster rate than the second one. So it will, the first one only will undergo the faster SN1 reaction. So here, so it means that um, option C is the, no, option D is the correct answer. It means option D. Then here it is told that which one of the following chlorohydrocarbon is it readily undergoes solvolysis. Readily undergoes solvolysis. Which one of the following chlorohydrocarbon readily undergoes solvolysis? So now the, the rule is that the more stable carbocation, the more stable carbocation formed, which will be formed from the alkyl halide, from the alkyl halide will undergo mm, will readily undergo solvolysis, will more readily undergo solvolysis. Solvolysis, it means it is hydrolysis only, where the solvent is the H2O. So if the solvent is H2O, then it is called hydrolysis, and if the solvent is something else, then it is called solvolysis. So now here, as we know that the benzylic carbocation is more stable due to resonance effect. So as we know that the carbocation, benzylic carbocation, which is like this, CH2 plus. So this benzylic carbocation is more stabilized due to the resonance effect, due to the resonance effect. Now here, for the first option only, the benzylic carbocation will be formed from this CH2Cl. Since why this Cl minus will be removed and CH2 plus will be formed. So um, and for the remaining ones there is no plus R effect. So the remaining ones are not very stable carbocations. The in case of option B, C, or D, the carbocations which are formed, they are not as stable as the benzylic carbocation. So hence the first one only will be uh, will readily undergo solvolysis. So option A is the correct answer. Then here it is told identify the products A and B in the reactions. Now the alkyl halide the identify the products A and B in the reactions. Now alkyl halide will react with silver cyanide. So from silver cyanide, as we know that isocyanide ion will be used as the nucleophile. So here we will have RNC, which is alkyl isocyanide, so which is A plus AgX. And in case of if KCN is used, then from potassium cyanide we will obtain the cyanide ion as the nucleophile. So here we will have alkyl cyanide, or I can have alkane nitrile, and then KX will be formed. So it means that the A is alkyl isocyanide and the B is alkane nitrile. So option A is the correct answer. Option A is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year KCET exam on the chapter Haloalkanes and Haloarenes. Still any doubts if you have, then please write that in the comments section. We shall obviously clarify them. And please install our Sapience Education application also, where we shall upload some important previous year questions on every chapter of chemistry, which shall be obviously helpful for your exam. So thank you everyone. Bye.